Hello, this is Yinchi Huang. I'm doing the homework 11 and problem 2. At this problem, it asked us to tell whether it is autocorrelation or the power spectrum. And first of all, we should know that if the R tau is the autocorrelation function of a real WSS process of xt, and it must be even, and R tau is less than or equal to R0, and its Fourier transform is non-negative. And we can find all these properties in the lecture note, but in the lecture note it didn't mention this property, but we can easily prove it because the expectation of xt plus or minus xt plus tau square root equals to the expectation of xt square root plus xt plus tau minus or 2 multiply xt plus tau, and this is larger than or equals to 0, and this one equals to rx 0 plus rx 0 to multiply rx tau, and it's larger than or equals to 0. So we know that the rx tau must be less than or equals to rx 0. And as we have these properties, we can begin to do this homework. First of all, if v equals to e to the power of minus v, and it can represent the autocorrelation function because it is even, and this one is less than or equals to e to the power of minus 0, and this one is 1, and we have the image like this one. So all of this is less than or equals to 0, and the Fourier transform of this is this one, and obviously it's non-negative. So and for the part 2, it may represent the power spectrum because it is larger than or equals to 0. And for the second one, this one, it can represent the autocorrelation function because this one is even, and the limitation of this one is 1, so it's less than or equals to 1. And so we can prove that rx tau less than or equals to rx0. So, and also for the Fourier transform, it's also non-negative, and the image is like this. So it can represent the autocorrelation function. And for the power spectrum, because it is non-negative, so it can represent the power spectrum function. And for the last one, it cannot represent the autocorrelation function because if we calculate its Fourier transform, it is this one, and it is not always non-negative, so it cannot represent the autocorrelation function. But it can represent the power spectrum because the f omega is non-negative. So the most important point is to know how to tell whether a function can represent the autocorrelation function or the power spectrum according to its own properties. And that's all. Thank you.